First problem here is find the explicit formula for an arithmetic sequence knowing that a sub 3 equals 94 and a sub 6 equals 85. So again, I'll use the a(n) equals a1 plus n minus 1 times the common difference to say that the third term, which is 94, must be equal to the first term, which is not known, plus n minus 1, 3 minus 1 is 2, times the common difference. And similarly, the sixth term, which is 85, must be equal to the first term, which is unknown, plus n minus 1, 5 copies of the difference. So now subtracting these from each other, 94 minus 85 would be, 94 minus 85 is 9, a1 minus a1 cancels, and 2d minus 5d would be negative 3d. And therefore the difference, must be negative 3. Once we know the difference is negative 3, we can back substitute into, say, that equation to notice that, let's do this one in a different color so we can distinguish the separate calculation and say that 94 is equal to the first term plus 2d, and d is negative 3, so that would be minus 6. And therefore adding 6 to both sides would tell me a1 equals 100. So then I can actually tell you what the explicit form is, right? The explicit form would be a sub n equals the first term plus n minus 1 times that common difference, which is negative 3. And so if we choose to distribute here, negative 3n plus a 3 on top of the 100, and there is our nth term. Okay, next problem is find the sum of the first 10 terms of that sequence. This is again arithmetic, and this time it looks like the first term is 8, and the common difference is, what do we take to add from 26 to 8 would be, let's see, 2 and 16, so that's 18. So the common difference is 18. So first let's figure out what the 10th term is. The 10th term is the first term plus n minus 1 multiplied by the common difference, and 9 times 18 plus 8, 9 times 18, and then add 8 means we're getting 170 for the 10th term, and so therefore the sum of the first 10 terms would be 10 over 2 times the first term plus the 10th term. And so when we do that, we're going to get 178 from the 8 plus 70 multiplied by 5 from the 10 over 2, and giving us 890. Okay, next let's do this one that has some decimals in it. The sum of the first 10 terms of this sequence. So the first term is 0.5, the common difference is a 0.8, because that's what it takes to add from 0.5 to 1.3. So that would mean that the 10th term would be the first term plus n minus 1, so 9, times the common difference of 0.8. Okay, and I know that 9 times 0.8 is 7.2, so adding on the extra half is going to give me 7.7. So the sum of the first 10 terms would be 10 over 2, first term plus last term. And so we're going to get a 10 over 2 is a 5. 0.5 added on to 7.7 would be 8.2. And so 8 times 5 is 40, and a fifth times a 5 is 1. So 40 and 1, that's going to be an answer of 41. And finally, the last one that's asked for here is the sum of the first 23 terms of this arithmetic sequence. So what's my first term this time is what I get when I plug in 1. 5 times 1 is 5. 5 minus 1 is 4. What is my 23rd term when I plug in 23? 5 times 23 is 115, and then subtracting 1 is 114. So when I want to find the sum of those first 23 terms, I'll take n, 23 over 2, times the first term plus the last term, which would be 23 over 2 multiplied by 118. And this time, instead of going 59 times 23, let's just do it here. So 23 times the 118 divided by 2. Looks like our final answer here is 1,357.